This section on API principles is the most important session of the API course in my mind, because it teaches you about the ways that we describe what we see in 3D and how we can report on that in a rigorous manner, one that will stand up to scrutiny and enable you to put into terms that people who are familiar with this process will be able to recognise and understand. And as I said, if you have to provide testimony in court or such, it will stand up to rigorous scrutiny. The principles. Core attributes of API are scale, which is all important, shape, size, pattern, tone, texture, shadow, site, and association. We'll discuss each of these in turn with some visual examples. If you have a set of anaglyph classes handy, have them ready, because there will be numerous examples in here which will be in 3 dimensions and which you'll be able to view with your anaglyph classes. Let's talk about scale. Scale is God in resource inventory and assessment. It's all important for a range of reasons. Firstly, it determines what can be done in what period and the usefulness of the data and limitations of the data that's finally produced. For example, if I said to you, let's go out and map the vegetation in Grafton or Sydney or any other city, and I said, we've got this afternoon to do it, that would decide what process you used, what classification you used, and limit the end usefulness of the data. Naturally, if I said to you, let's go out and map the vegetation in your local city, and you've got the rest of your life to do it, that will produce a completely different product, will define a completely different classification to use, and the end result will have a completely different set of uses. Okay, so in those terms, scale is the most important thing that you can do. Or deciding on a scale is the most important thing that you can do. It's also integral to the evaluation of objects that are observed in stereo analysis. Larger scales permit clearer viewing and can offset to a certain extent the effects of graininess or any limitations in the imagery. In resource inventory, we generally call a small scale something in which the objects appear small. It's the easiest way to remember it. If you take a photograph from the air of a town and all you can see is the roof of one building, that's a fairly large scale. If you can see the whole town in the one photograph, that's a fairly small scale. So just bear that in mind. Scale also permits relative size assessments. If you know the size, say for example, of your average road in terms of width, it might be 6 or 7 metres of bitumen with a bit of gravel on the sides. Well, if you know that something's 6 or 7 metres in the photo, you can therefore look at something else and you can apply what you've learnt from that to the other object and make some assessments of size. Obviously it might be a completely different size on one photo compared to another because the scale varies, but you can still make relative size assessments. And it can be used to make estimates of things like those that are mentioned on that point: tree canopies, road widths, etc. So scale's hugely important. Shape. Very diagnostic as well. It can tell you a lot about the objects in the photos or the images, especially when you ally it to an interpreter's knowledge, training and experience. And those are 3 terms that I'll stress as we move on. This image at the right shows 2 particular shapes, a fairly regular one here and a fairly uncoordinated set of shapes down here, and allied with tones and textures and such that an experienced interpreter can make out what this particular land use is here, and someone with a specific knowledge of the horse racing industry could probably tell you pretty much what that is. One's a training track, and one's a hard rock mine. And the reason we know it's a hard rock mine and not something like sand mining is if you look over here, you can see a steep cliff face casting a deep shadow. Sand generally doesn't tend to have steep cliff faces. It generally has an angle of repose similar to what we can see over here. Okay, let's move on. This is a really interesting image. It's actually an anaglyph, and it shows a characteristic shape in cultivated land that can actually persist for an extended period of time after cultivation has been replaced with pastoral-based land uses. And I'm talking about this, what would you call it, a double-ended teardrop, if you want to think of it that way, a lens perhaps, tapering towards each end, where you can see a cultivation implement has been dragged around a tree or an object in the paddock which is an obstacle to its path. This is a very recognisable and indicative shape, and in later slides I can actually show you how you can recognise it in areas long past cultivation. Interestingly, you'll see at the bottom of the image here very small versions of the same thing, and analysis will show you that these actually are fence posts that are in the actual cultivation paddock. The fence has been moved out a few metres, and the cultivation implement still has to navigate around the fence posts because they haven't been removed. So little things can be indicative. So as I said, characteristic shape. We'll talk more about shape later. Size can be useful when referring to buildings and objects of known size, and as I said before, we can use that to help size other objects. For example, in this scene we have an avocado and banana plantation. This finer texture, which we'll talk about texture later, is bananas, and these blocky blobs are the avocados. That's a technical term, blocky blob, by the way. You'll see a path, a vehicle track down through the plantation to some sheds. We know basically that vehicle tracks, and you can tell looking at it closely, it's a single vehicle track. We know roughly the size of buildings in terms of average sizes and such. We can cross-reference the width of the road with the widths of the buildings and make some estimates about the size of each. And if you look, the width across the road is about 3 metres, width across some of these trees is about 3 metres, so there's some cross-referencing there that you can do to make estimates of, say, sizes and ages of vegetation. It's also directly related to scale. If you measure this distance across here, it's going to be 3 metres no matter what the scale is, but at this, if I blew this scale up so that all you could see was a smaller area around here, it would fill a much greater area of the whole photo, and so it would still be 3 metres, but the measurement that you make of it will be much larger. I hope that makes sense. Here's a main road, two-lane road, a bridge going over a river. If you allow a couple of lanes for the normal lanes, say 4 metre width for each lane, it's 8 metres of road, plus a couple of metres on the side, 10, so 12 metres across we estimate the bridge at, which ties in with about 12 metres across part of the roof of this house. Gives you an idea of the canopy size of this tree. You can see here driveways, a single driveway with 2 individual concrete strips for the tyres. It's not a double driveway situation because you would expect it to be 3 metres across each one, and we know that 3 metres is about the size of one lane on the road, so we know that it's a single driveway. So little things like that can actually help. This is actually an anaglyph image, and if you use your glasses you'll be able to see that these trees there's quite a significant tree over here, nice big crown. This is 10cm imagery 2 from the API 40, so it's got quite good resolution. If you want to look at that in 3D, just pause this. Okay, pattern. Pattern's quite diagnostic, perhaps the most diagnostic, and ordered arrangements of land use can permit quite a bit of information to be derived about what's going on a site. Pattern, as I've mentioned before briefly, is closely related to association. You might remember the trotting track of the quarry, two patterns, but in that case not associated with each other. In this particular image there's patterns and tones and contrasts of land uses that are associated with each other. You'll see a drainage line along here. You'll see large square areas, one up here and one down here, that have a very pale and even homogeneous toning. That's in fact water with a high concentration of dissolved clays and things in it, very turbid water, associated with areas of very even land use in rectangular paddocks. This is actually an area of irrigated cropping, of high flow water being stored off site in creekside storages, being used then to subsequently irrigate these areas of cropping. So the pattern and the tones and the shapes and the colours and things are all working together there to help your determination of what's going on in the landscape. Regular areas suggest specific uses. This is a regular area, regular shaping, very fine striping across the landscape, long thin stripes. You might remember the different look of the avocados a couple of slides ago. This is a completely different arrangement, but it's a similar land use. It's horticulture, it's vineyard or trellis planting, so you have long thin strips of things like grapes or kiwi fruit or trellis type vegetation. This is an anaglyph. You'll see the same sort of pattern here. This is blueberries grown near Coffs Harbour. You'll see paddocks where you have long thin strips, no great big bulbous plantations such as in an orchard. There's a pattern in this area here, a couple of features in this that are quite diagnostic. You'll see this elongated pattern of like dashes in the landscape, generally heading in the same orientation, and you'll see that in the areas where they exist there's a fairly fine and uniform colour to the background, whereas in areas where they don't exist it's a lot more diverse, a lot more dotty and cluttered, if you want to think of it in that way. And this is indicative of windrows of vegetation which has been cleared away from the areas where there's no pattern and lined up across the slope in order to minimise concentration of rainwater runoff to prevent erosion. So it's a clearing up of scrubby materials or weeds and such, piling them up into windrows of vegetation across slope. So it's a diagnostic pattern. There's another pattern here where you have windrowing. It's generally on contour around the hills. This is an anaglyph as well. You'll find that the drainage lines in this case have not been cleared. They've actually had vegetation retained on them to prevent erosion and soil loss. What you find is that where these windrows are on contour, they will tend to prevent soil erosion, but this is quite an extensive area of clear felling, possibly for implementation of a completely different land use. Now, this is another similar area of vegetation management, but it's a little pockmarking of a forestry area as opposed to a clear felling as would have occurred in this area before it was put down to pasture. And this is a technique known as Australian group selection. This is also an anaglyph, and you'll see that small areas of timber have been cleared completely and trees removed, and this is allowed to reseed and regenerate with an input of seeds from the surrounding forest area, and it's a technique that's widely applied in some areas, certainly on the north coast, but also in other parts of the state. Okay, I might just leave that there for the time being, and I'll come back in part 2 of this to talk about tone, texture and the other features, other core attributes.